Hello everyone, my name is Fang Yuzhou. This is a presentation demo for a final project of course Image Processing and Computer Vision of Dr. Wu, University of Florida. And the topic of the project is object tracking system based on the CamShift algorithm. Object tracking is an important research topic in computer vision area. The rapid increase in number of high-speed PC and availability of high-quality and precision video cameras make the use of object tracking system more and more widely. Object tracking can exist in almost everywhere nowadays, such as public surveillance system, navigation system, like the newest auto-drive car, and for medicine use, or even implemented in video games nowadays and etc. As it has been researched for years, many algorithms has been developed to achieve object tracking. These algorithms can be separated into three kinds. The first is a kernel-based method like CamShift Algorithm and CamShift Algorithm, which is used in this paper. And the second is a feature-based method like KLT algorithm. The third is a Soho-based algorithm. These algorithms usually track objects based on its edges. In this program, I present an object tracking program for real-time video from webcam based on CamShift algorithm, use Python and OpenCV. Let me introduce the CamShift algorithm first. CamShift algorithm is based on CamShift algorithm, which uses color information to track the object. This algorithm consists of three steps: the back projection, CamShift algorithm, and CamShift algorithm. To track an object, we need to do back projection first. Since the color in RGB is very sensitive to variance of illumination, the image should be converted from RGB coordinate to HSV coordinate. Then we can draw a histogram of hue component, so that we can replace values of the pixels in the image with a color probability to get a probability distribution image. And all the calculations were based on this grayscale image. Figure 1 is the experiment of back projection. The top image is the original image. I choose the 10 as a potential track image in this experiment. The middle is the probability distribution image after binarization. From this image, we can see after back projection, the object we want to track is separated from the rest part of the original image. After back projection, we are going to apply the CamShift algorithm based on the distribution image. The flowchart is on the left of this page. After we get the distribution image, we need to initialize a search window with a size and location. Then we need to find the centroid of the object by calculating the zeros and the first moment. The formulas are set in the middle of this page. M00 is a zeros moment, M01 and M10 is a first moment, XY is a position, and IXY is a distribution at the position XY. And the coordinate of the centroid xc equals to m10 over m00, yc equals to m01 over m00. When the object centroid is found, the algorithm moves the centroid of the search window to the centroid of the object till the threshold is fulfilled, and it converges. Figure 2 is a sketch map of the convergence process. The red point is the center of search window and yellow point is the centroid of the object. The aim is to make them overlap. The final step to achieve tracking is CamShift algorithm, in which we use CamShift algorithm for every frames in the video. And for each frame, we use the search window size of the current frame as the initial window size of the next frame. And in this step, the window size will automatically update. To achieve this, we also need some calculations. In addition to the CamShift algorithm, we need to calculate the first and the second moments in this step for x and y. They're m11, m20, m02, and based on them, we can get three parameters r1, r2, and r3. Then using these three parameters, we can calculate the orientation theta of the major axis and the scale of the distribution L and W by finding an equivalent rectangle that has the same moment. Then the search window will automatically track and adjust the tracking object. Here are some pros and cons for CamShift algorithm. Although CamShift algorithm is a simple algorithm, it can conceived for dynamic evolution of the distribution and track very fast movement. Besides, it can adjust the search window automatically with the object we want to track. However, this algorithm is a color-based algorithm and use only the color information as a source. Therefore, the performance will not be good at some circumstances. There are some results and experiments of the project. Figure 3 is the image before starting tracking. After using mouse to select the green pack, the pack is under tracking like figure 4. When I move the pack, the direction of the movement is shown in the screen. In this experiment, I changed the appearance of the object. In figure 7, I turned the pack to a different angle toward the camera. In figure 8, I changed the distance from object to the camera. In figure 9, I sheltered part of the object. And in figure 10, I quickly shake the pack. In all these experiments, the system performed well. In this experiment, I used different objects to be tracked. In figure 11 and 12, I track a small white box, which has a similar color as the background. When I change its appearance to some extent, the system started to track the wall instead of the small white box. In figure 13, I tracked the stain on the banana, but when my arm went to the videos, the system tracked both the stain and my arms. This bad performance comes because the object tracked share the similar color with the background or other objects in the video. Here are my conclusions. In this program, I present a color-based CamShift object tracking system. It's a simple system and easy to achieve. Good performance comes when tracking object has a unique color in video, and bad performance comes when tracking object has a similar color with the background or other objects in video. One method to improve the system performance is to use a camera that has high resolution and high contrast, so that the color between different objects, the objects and background, can be more obvious. In the end is my reference. Thank you for watching, and the next part is the explanation of the code and presentation of the tracking system. This program is written in Python 2.7 using OpenCV. In the first part of the code, I define a function to allow the mouse to select a region and capture the image of the selected region. Then in the second part of the code is to initialize the track window based on the region selected. Then the third part of the code is to convert the image from RGB to HSV and draw a hue histogram for the region of interest and set the threshold. And then in the main loop is the CamShift algorithm, and followed by the display function of the direction of the object. And here my presentation. Before the tracking, you can see I hold a small pack that will be the tracking object in this presentation. At first, I use the mouse to draw a rectangle to select this object. And then you can see this object is in the blue rectangle that we tracked. When I move this object, the direction information will be displayed in the screen. And when I move far from the screen and change the appearance of this object, you can see the tracking window is still stick to the object.